Moving on, post our meeting session and the networking breakfast and high tea session, the next corporate presentation is again a very unique session and something that is a core concern for the industry as well. So please help me welcome the next speaker on stage with a big round of applause. Joining us, Mr. Manoj Bansal, Head of Business Development, Material Characterization and Molecular Spectroscopies Business for India and South Asia from Thermo Fisher Scientific. A big round of applause to Manoj Bansal ji. Welcome to the stage, sir. Mr. Bansal will be presenting on the topic of development of meat analogs using twin screw extrusion method. All over to you, Manoj ji.
Thank you very much and good afternoon to everyone. Since we are already running late, so without much ado, let me share my slide deck. So, Thermo Fisher is a primarily instrumentation company. So we have variety of instruments. So today I will restrict myself to lab scale twin screw extruder, which help researchers globally to develop meat analogs. So twin screws can be used for extrusion of food products of very wide variety. So of them are noodles, puffy products, snacks, and of course meat analogs, which I am going to cover in this presentation. So meat analogs are basically plant-based products uh, where they are rich in protein, but they have absolutely no content of meat or animal cell. So researchers globally are working on this, including mostly European and American institutes, and also in India, a lot of companies are working on this very exciting area. So why should we have meat analogs in the first place? So they are replacement of animal content by plant-based protein. They resemble meat like, in terms of taste and texture, they very much resemble like meat. And to meat eaters, it is a good change, from turning from animal consumption of animal cell to plant-based protein. They are really nutritious and also reduce drastically the risk of cancer and other ailments which meat could introduce, or maybe quality of meat could introduce. So it also lowers saturated fat, and it's very healthy as a replacement of animal cell. So these are some of the benefits. I mean, it's really good and tasty in terms of texture and mouth feel, and still a plant-based product. So this is how a schematic of extruder would look like. So what you see here on the screen is feeder. So where you can introduce powder plant-based protein products incorporated with water as a plasticizer or a major content, which will give also help in inducing a textured structure in the final product. So then we have to feed water, as I said, because it works as a plasticizer, and then you have a barrel which will process the material. This barrel essentially contains two screws which applies specific energy or mechanical energy which will shear the material. So when your material is heated and sheared, it gives rise to a very nice product which has a very good mouth feel and of course a texture as well. So basically, we are harnessing the power of our twin screw extruder using making two screws rotate in the same direction. It could be clockwise or anti-clockwise, but both in the same direction. They apply shear, melt the product, and we also impart electrical heating just to maintain a particular temperature. But over a period of time, when the extruder has achieved stability, so there is no more need of supplying electrical power. So shearing itself is a very good temperature controller, and it provides a lot of heat energy to the product. So this is why extruders are called extrusion cookers. Basically, they cook the material. So by the time material comes out of the barrel, it has already been processed inside the barrel, and there is a die. Die will basically decide the shape of the product which is coming out. It could be a sheet, it could be a noodle, it could be a strand, little thicker strand, and you can also introduce air to puff it. So depending on what you are working on, but the twin screw does not differentiate between what you are running on. It acts as a mechanical stabilizer and mechanical processing machine. Depending on what you are doing, you can add or delete the quantity of water, quantity of different gradients, depending on the taste and what product you are working on. So this is what is done using twin screw extruder. So there is a thing called diameter uh, of the screw of the twin screw extruder. So larger the diameter, larger would be the capacity, and the extruder is capable of producing more and more per hour. So depends on the application and throughput needed. You can choose a particular machine of a particular diameter. So for instance, we manufacture 11 which is primarily a R&D machine where you can produce something like 2.5 kg per hour. So it is really ideal machine for development of new products because it does not waste too much of product. Before you arrive at the right recipe and right product, you may have to run the extruder for a couple of tests or several tests, I would say. So if you have a very big extruder, you would be ending up wasting a lot of material, expensive material in the form of protein powders and other ingredients, and it will also bring down the productivity. So to start with in a new experiment, it is always good to have a small machine where you can try out different recipes, different experiments before you get the final or perfect product. So we manufacture 11 that is a core R&D unit, and then something in between, which is we call pilot scale level, which has a diameter of 16 So there you can talk of something around 5 to 6 kg per hour. And then our production machine, or still a production pilot scale production machine, is having a diameter of 24 So that means this can give you something around 20-25 kg per hour, depending on what product you are running on. So scale up is always a key to all such designs. Unless you scale up what you develop on a R&D extruder, it makes no sense to use a production extruder. So all extruders invariably should be scaled up, and in our case, it is a cakewalk. Once you develop a product on a R&D scale, you can very easily scale it up on a production machine. Then inside the extruder, the design screw profile would decide how much shear energy you are imparting to your samples. So you can change the screw profile for a better product, for a variable product, and then temperature also would play an important role in flowing or making the materials flow inside the barrel. So these are the parameters which will govern how good or bad the product would be. So when it comes out of the die defines the temperature. Basically, depending on what you are running, you can keep die at a particular temperature to facilitate solidifying of the product and also flow through the die. Die also defines the shape of the product. As I said that it could be a noodle or it could be a sheet. In our meat analog experiment, we used a die which was a sheet, so product will come out as a sheet. So as of now, of the total meat market globally, which is estimated at $14 billion, meat analogs, they only constitute 1% of the total market. But by a estimate, a report, it is going to reach around 14 billion, $140 billion by 2029, and it would play a very significant role in this food market. So meat analogs are essentially high moisture meat analogs. So high moisture means we put water which is in excess of around 40%, could be even more. But this is how the water plays up as a plasticizer and ensures that when the product comes out of die, it has a very meat-like texture basically. So essentially what we are doing here, we are mixing protein powders with water and other ingredients as may be necessary for the recipe. And then we shear it inside the extruder. So mixing takes place. And because of that mixing at a very high dispersion level, it imparts it a structure and a texture which resembles meat. And finally, when it comes out of the die, we have to choose a dye which can solidify the product. So it should not happen that when the product is coming out of the dye, it is very flowy, or it is very weak in structure. So we need to ensure that dye has to be designed in such a way that it imparts the texture, necessary texture to the product. So essentially, it is a combination of material properties, kind of material we are feeding into the extruder, and then finally how we process the material inside the barrel, and when it comes out of the die, what we want of it. So flow characteristics are defined by what kind of shear rate we are giving. Shear rate means how fast or slow we are moving the extruder. That will increase or decrease the mechanical specific energy that is going into your sample. And then finally the temperature of the die. So if we keep the temperature of the die when the product comes out very high, it would be very soggy and sort of a liquid sample. This is what we don't want in meat analog. It should be a solidified product which should resemble meat, both in terms of taste and visual looks. So die temperature has to be controlled at all the times just to have a good quality of product. And to have this solidification happening in the die, we need to have a longer die than normal extrusion processes. Because here we would like die to retain the product for longer duration, it has to be longer in length. This is how the barrel would look like. What you see here inside is a combination of two screws which will have different zones. So basically for conveying the material inside the extruder and then finally shearing it before it comes out of the die. So extruder is divided into different zones. Each zone can be controlled simultaneously and independently in terms of temperature. Whatever you set the temperature will impart the structure and texture to the material. So it is essentially a mechanical process where you are mixing some water to the ingredients, shearing it, applying temperature, and allow it to remain for the adequate duration so that extrusion cooking takes place, and the material when it comes out, it is already good quality of material. So let me show you a small video how we did it in our Karlsruhe lab, which is in Germany. So here we used wheat gluten. So this is a small R&D extruder, and what you see here on the top, on the right hand side is a melt pump, oh, sorry, water pump. This is a longer die. Water pump introduces water at a very defined quantity, and this is how the product is coming out of the die. And if you see, the die is quite long. It doesn't happen normally with twin screw extruders. They have a plate die which will have a hole, and the product will normally come out as a strand. So see how good is the texture of this product. So die temperature, as I said, that plays a very important role in solidification of the product. So in this experiment, we use two temperatures, one at 90 degrees and another at 135 degrees. So the kind of product that we got from when we kept the temperature at 90 was this, what you see on the left hand side. Sorry, there's a technical glitch here. Yeah, in another experiment, we kept the temperature at 130, 135 degrees. So the kind of texture we got was different. And we compared when both the products, you see the product on the right hand side had a better texture and structure, which resembles meat in a better way than the product on the left. So you can change different temperatures, you can change different processing conditions inside the extruder to arrive at a optimal product. There's a lot of flexibility that the process offers you. Then also the screw speed of the extruder plays a very important role. Higher the screw speed, higher would be the shear gradient. You see, to impart it a structure, should flow in a axial movement. So the product which is very very close to the barrel periphery would not move at all, and the product at the center would move the maximum. So it creates a velocity gradient, and this velocity gradient is primarily responsible for imparting it a texture and structure. Again, same thing here. So velocity gradient comes from longer die and screw speed. So this is one of example of the die that we have. It has different dimensions, I would say. So what we used here is 5 mm thickness, and it produces a sheet. So likewise, on a bigger extruder, you can have bigger dies depending on what exactly is the throughput needed. So that's all for my presentation. So I would welcome if you have any questions on the process or any of the other things I discussed. So you can take this in the stage. Sure.
So, ladies and gentlemen, first of all, a big round of applause for Mr. Manoj Bansal for that wonderful session on development of meat analogs using twin screw extrusion. In the interest of the time, we can take one quick question, but just to tell you that Mr. Bansal is available throughout the day. So, any further questions you have, please feel free to reach out to him, and I'm sure he'll be happy to help you with the answers and the solutions. Any questions? Can we have a mic for Milanji? Yeah, coming.
Sir, the
Milanji, if you could also introduce from your organization, that would be great.
myself Milan Chaudhary. I am quality head in Sabar Dairy Rohtak plant. We represent the Amul in Haryana. And my question to you is that, sir, we are talking about gluten free, sodium free, salt free, sugar free, and this is the product from gluten.
So there are variety of materials that you can use. So in this example that we conducted at our German laboratory, we used gluten.
Hmm.
So you can use soya, you can use different products.
Hmm.
So that machine per se does not differentiate between what you are doing. It's a matter of how nutritious you would like to keep the product. Idea is to introduce to the people higher protein content, people who do not consume meat.
बट हम खाते रहते हैं सर, सोया चाप मिलता है या घर पे छोटे थे तब से सब्जी खाते रहते हैं। इट्स तो इट रिसेम्बल एज अ मीट या चिकन या वॉट एवर इट इज, बट माई क्वेश्चन इज इट्स नेम इटसेल्फ मीट एनालॉग। तो ये मेरा इसके इसके बाहर का क्वेश्चन है सर कि मीट एनालॉग है, पनीर एनालॉग है, तो हमें इनका नाम पनीर एनालॉग जैसा टोफू आता है, ठीक है, तो मीट एनालॉग ये सब के इट रिसेम्बल्स एज अ मीट, दैट्स व्हाई इट्स कॉल्ड एज मीट एनालॉग।
Okay.
तो
So I'll
उसका
answer. I will
उसका
answer.
कोई अलग नामकरण क्या होना चाहिए, नॉमेनक्लेचर?
So that's what industry knows it. I mean, it is called meat analogs. So basically, it's a fake meat which is made of plant-based proteins. So it is up to you, whatever name you want to give, but the product is really good. I tasted it myself. I am a Jain vegetarian, but the product looks like very, very tasty. And people who would like to still enjoy meat but do not want to eat meat can definitely try this product.
अच्छा, एंड हाउ इज द मार्केट
Market
एस्पेशली
is
इन
growing.
इंडिया?
Market is growing. We see a lot of new players, including startups and big corporates as well, getting into this market. So I think in the years to come, this would gain maximum popularity.
It is available in India, na sir,
Yes,
right
yes,
now?
very much.
अच्छा. Which companies are
Lot
working
of
on it?
companies, lot of companies. I don't consume, but there are a lot of companies you can find on Amazon or
नहीं,
Flipkart and
मीट
all.
सर, मीट खाने वाला मीट ही खाएगा, पनीर खाने वाला पनीर ही
No,
खाएगा. आप
unfortunately,
नहीं,
it is not true. It is
इट्स
not
नॉट
true.
लाइक दैट. आप एज अ कंज्यूमर बात करो कि मुझे पनीर खाना है, ठीक है, कोई बेच रहा है पनीर एनालॉग या मीट एनालॉग है, ठीक
Okay.
है.
To answer your question in simplest terms,
हम्म.
many people have allergy with food, milk-based products. So they can try tofu, which is very good option. So why to compromise on your diet intake of protein, or for that matter, other nutrients? So this is why these products are being manufactured, developed, and they are consuming. They are being consumed by a lot of people. If you see the data has come from one of the very reputed market agency. So by 2030, my guess is, it would even grow larger than what I have shown.
यस सर. एज ए वेजिटेरियन वी लाइक दिस मीट एनालॉग, ठीक है. मैं पसंद करूंगा कि सब मीट छोड़ के ये खाए, ठीक है. पर इसमें क्या होता है, अब सारी एनालॉग 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 प्रोडक्ट आते जाएंगे. इट्स टोटली एडल्टेटेड प्रोडक्ट्स, या इट्स नॉन क्वालिटी प्रोडक्ट्स विथ दैट पर्टिकुलरली दैट ओरिजिनल प्रोडक्ट. तो मैं अभी तो मैं पनीर एनालॉग है, मीट एनालॉग, दो मीट एनालॉग ये नया है मेरे लिए. तो और चीजें आ सकती है. तो माय सबमिशन इज दैट कि ये सब कोई संस्था काम कर रही है सरकार के साथ या फसाई के साथ, कि ये रोकना चाहिए एक जगह पे. थैंक यू.
To be very honest, I am not aware of if somebody, and why should somebody stop this product from coming to the market? That's the question. It's a free market, let the product be in the market. What stops? Where's the problem?
Thank you, Manojji. Thank you, Milanji. I think we can
But
always.
just to add one thing,
Yeah, please.
if you permit only.
Yeah, sure, sure. Please, ma'am. Please
You
go
have
ahead.
a very good question. I must appreciate that कि analogs बनते जाएंगे. मेरा question आपसे था मनोज जी कि इनकी बात सही है कि हम जब एनालॉग बनाएंगे, हमें पनीर खाना है, पनीर हमें नुकसान कर रहा है, बिकॉज आप मेरा एग्जांपल लीजिए तो आई एम अ थायराइड पेशेंट, आई कैन नॉट टेक सोया प्रोडक्ट, और ये सारा चीज़ें अब सोया से बन रहा है, मीट मैं खाती नहीं, आई एम लाइक यू, नहीं खाती हूँ, आई एम अ प्योर वेजिटेरियन. बट इन चीज़ों को जब आप बना रहे हैं, व्हेन यू आर प्रोड्यूसिंग दिस काइंड ऑफ थिंग एंड कंपनीज आर हेल्पिंग एंड असिस्टिंग एंड इट इज़ वेरी पॉपुलर, व्हाट इन टर्म्स ऑफ फूड सेफ्टी आर वही प्रोटीन वाला सोया वाला स्टैंडर्ड इस पे अप्लाई होगा सिंपली. एंड ही इज करेक्ट, अगर इस तरह की नई मार्केट लाइन आ रही है तो उनकी सेफ्टी और उनकी एडल्ट्रेशन के लिए कुछ है, मतलब बिकॉज यू आर फ्रॉम द इंडस्ट्री, यू कैन, इट्स ओपन मार्केट. नहीं, दैट्स फाइन, उसके लिए मेरा कोई नहीं है कमेंट, बिकॉज इट इज अ मार्केट, एवरीबडी हैज राइट कम विद एनपीडी. बट ओनली पॉइंट इज की जो सेफ्टी की बात है उसको भी कहीं ना कहीं आप एड्रेस करते
Say
हैं
in
या-
India, the packets I have seen, they are all governed by, I don't know, accreditation from FSSI, but I think the company who is developing a product like this, innovative product, so I think they must be taking care of all quality aspects. I can't expect a company, who is getting into a product as innovative as meat analog, and I cannot just fathom that they would not, put lot of efforts to maintain the quality.
Thank you, Manojji. I think, for the interest of the very, very interesting discussion, by the way. But I requested to take it, because we have to run, the next sessions as well. But thank you so much, Manojji. Wonderful having you here. Just want you to kindly be here for a few more minutes. I would like to call on stage Mr. Shamal Roy, head of QA and PD from Pious Milk Producer Company, to kindly come on stage and felicitate our speaker, Mr. Manoj Bansal from Thermo Fisher Scientific. A big round of applause, ladies and gentlemen, once again for Mr. Manoj Bansal, Head of Business Development, Material Characterization and Molecular Spectroscopy Business, India and South Asia from Thermo Fisher Scientific. Wonderful session we heard, development of meat analogs using twin screw extrusion. Thank you, Manojji, for that wonderful session, and thank you, Shamalji, for doing the honors.